Hello, my name is Jim Bullock from iFormulate Limited in the UK, and I would like to thank Agropages for inviting me to speak to you today at the Formulation and Application Technology Congress. My talk today is entitled Crop Protection Formulation, Why is it still important and where is it going? And here's an outline of my talk. I'll start with an introduction. And then I will talk about formulation types in the market before moving on to talk about new developments in solid formulations, as well as new developments in liquid formulations. I'll then be covering the topic of biological formulations before ending with a summary and some tips about how to learn more. Let's start by explaining a little bit about iFormulate. iFormulate is a consultancy company founded nearly 10 years ago by myself and my colleague David Calvert. We have a long range of experience in the chemical using industry. We have diverse experience, knowledge and a wide range of contacts. We also use associate partners on our consultancy assignment when we need them. We don't just work in the agrochemical industry, but we work across all industries that use formulation science and technology. We have experience in a range of different functions, including consultancy, innovation, R&D, business management, strategy, training, and so on. You can see our contact details here. And our services are divided into three parts. The majority of our work is consultancy work, mostly for companies who want to ask us to help them with their formulation challenges. We also do a certain amount of skills work, so training in formulation science and technology, both online and in person, both public courses and customized courses. And we also do strategic work for industry bodies as well. For instance, we helped as part of the team that set up the UK's National Formulation Centre. So let's first of all take a look at formulation types in the marketplace. And a couple of years ago, we wrote a report called Formulations 2020, where quite a lot of this data that I'm describing to you today is taken from. And one of the things we looked at, we took some data from the pesticide manual to find out what are the most popular sorts of formulations on the market for pesticides. The numbers that you see here relate to the numbers of active ingredients formulated as those specific types. Later on, as you'll see, we'll cover market value and the value of those different formulation types. So in terms of popularity by numbers of AI, you can see that the traditional formulation types, this is the chart for solid formulations, the traditional formulation types are WP, water dispersible wettable powders, WG, water dispersible granules, GR, granules for direct application, and DP, dustable powders. So they're very much the traditional types which are popular for solid formulations. When you take a look at liquid formulations, you can see that by far the most popular types are EC, emulsifiable concentrate, SC, suspension concentrate, and SL, soluble liquid concentrates. And the vast majority of active ingredients are formulated in those three formulation types. You can see that some of the more innovative and newer formulation types are rather less common in the market. So for instance, oil and water emulsions, oil dispersions, microemulsions, capsule suspensions and suspo emulsions are really only used as problem solver formulations. So they're not mainstream. If you can formulate, you're going to formulate in one of the top three types on that list. But if you have problems or you have some special needs, then you might want to employ one of the more sophisticated and complex formulations that you see on that chart. The next thing we did as part of that report was to look at the market value of different formulation types. So we took every product on the market, we used a commercial database to look at market value. And we then ranked the formulation types in order of market value. And the data is a few years old, but I don't suppose it has changed very much since then. Suspension concentrates by market value represent 1/4 of the market, so 25%. Emulsifiable concentrate, 23% of market value, and SL, soluble liquid products, 18%, so that you can see well over 50%, 60% of the market is represented by those three liquid formulation types. The solid formulation types are of lower value, so the next most popular by value: water dispersible granules, wettable powders, and solid granule formulations. And you can see that that value of the liquid types is overall much higher than for the solid types. Let's take a look at what we think are the market drivers for the development of formulations currently. Well, the ones that never go away and that are persistent from year in year, of course, cost effectiveness and safety and environmental acceptability. Those two wouldn't be at all surprising. I think one of the most important drivers at the moment is the need to develop combination products, and you'll see particularly for the increase in resistance of pests and weeds, that combination products with multiple active ingredients are being formulated for the market. And we're also seeing a number of mixed products containing both a biological active and a synthetic active coming onto the market, and we'll give you some examples of those in later slides. So combination products is another market driver for formulation. And then the topic of biological formulations, which we'll also cover later. But certainly the market has seen a need for improved biological formulations, both in terms of stability and of efficacy. And then there are some specific factors that might drive development in formulations. And those include, for instance, the upcoming EU restriction on the use of microplastics, which we expect will affect formulations based on microcapsules and on seed coatings. So let's move on and take a more detailed look at solid formulations, and here I wanted to give you some examples of new developments both in the market but also in patents and in publications. So again, for the Formulations 2020 report, we carried out a patent survey on solid formulation types. What we did notice that there are really very few patents, or relatively few patents, for WG formulations. There were a few examples which I've listed there, but I would say they are not particularly innovative formulation types. We've got normal types of formulations and normal co-formulants being used in a typical way. So there was nothing particularly special about the patents that we found that had been filed over those years. I would say that there were more patents on GR formulations, so granules for direct application, and some of these relate to controlled release functionality, and there is some focus and an amount of activity on biocontrol formulation products which are formulated by as GR as well. Let's give you an example of some of these solid formulation patents, and there are a couple of interesting examples of solid nanodispersions that we found. In this example, pyraclostrobin fungicide was used as the active ingredient. That active ingredient was dissolved in a solvent, ethyl acetate. It was then added to an emulsifier, a typical non-ionic emulsifier, as well as a surfactant, a further surfactant, and anionic surfactant. And those two together provided both steric and electrostatic stabilization. This mixture was able to self-emulsify to form a nanodispersion. And here you can see the very fine particle size measurement on the lower left hand side of that nanodispersion, and also the same thing under SEM microscopy and image analysis. So you can see that the particle size range is in the order of 10 to 20 nanometers, so very, very fine dispersion. Then a carrier was added. In this case, lactose was added as a carrier to the formulation, and the formulation was then dried, so both water and the solvent were removed from the formulation to form a solid nanodispersion. So we had a redispersible matrix, that was the lactose, the carrier, and within that was dispersed the solid active ingredient. So very, very fine particle size, and presumably that acted to improve the bioavailability of the active. And indeed, it was found that compared with the WG formulation, there was better retention on the leaf, there was a lower contact angle, so better wetting, and a better antifungal activity than the WG formulation. And that's reported in a journal. There's the link there if you're interested in reading some more about that. There was a second similar example of these solid nanodispersions. In this case, emamectin benzoate was used as the active ingredient, again dissolved in a solvent to form that oil phase, and then some typical surfactants were used to emulsify that oil phase into water. A carrier was used, in this case sucrose. In this case, freeze drying was used to produce a solid nanodispersion, so altogether with 15% active ingredient, 20% surfactants, and the rest was carrier. And again, you can see a very fine particle size here, somewhat larger particle size, about 100 nanometers in this case. And again, claims were that the leaf surfaces were better wetted, there was better retention and a higher bioactivity than a typical WG suspension formulation. And again, we provided you with the reference if you're interested in reading more about that article. As we mentioned before, there is activity in direct granule controlled release for directly applied granules, so not water dispersible granules. These are for direct application, and there are several recent examples of publications, so examples of controlled release granules of pymetrozine for rice paddies, where the active ingredient would normally hydrolyze quickly in conventional formulations. In this case, the active ingredient was mixed with a bentonite carrier with a typical anionic component, the dodecane sulfonic acid, as well as calcium lignosulfonate. This mixture was then added to core particles of bentonite clay in a pan granulator to form those granules around the core. And then at the end, a dispersion in ethanol of epoxy resin and polyamide resin was sprayed over that mixture and cured to provide a seal around the outside of the granule. And this was said to have a good controlled release properties and good efficacy against target insects. And there is an example of that controlled release profile measured over a period of up to 60 days after application. And again, if you're interested in reading about that, there's the journal reference for you to follow. There were some further examples of controlled release granule formulations, including on the market, Bayer's Admire CR, which is a controlled release formulation of imidacloprid, which has a low concentration in paddy water and in surface soil than conventional GR formulations, so reduced environmental impact. FMC have Suscon Maxi Intol, also a controlled release formulation of imidacloprid with a longer lasting efficacy and again requiring a lower active ingredient quantity to control the target pests. So there were just some examples of developments in solid formulations. Let's move on to some new developments that we spotted in liquid formulations over the past few years. So I've mentioned before that because of resistance, there is a drive towards combination formulations with multiple active ingredients, and I've given a couple of examples of commercial products that are combinations, liquids. So Bayer have an OD formulation, oil dispersion formulation, Betanel Max Pro, which consists of 4 active ingredients, and Bayer say that you've got to consider state-of-the-art solvents, you've got to use emulsifiers and wetting agents to ensure good distribution of the active ingredients and coverage of the leaf surfaces. So there's some claim there from Bayer about good adjuvancy properties being given by the formulation ingredients. And this product is said to have a better distribution on the leaf surface when compared with a conventional SC product, which is used together with an adjuvant. Then there's an example from Syngenta. So Trivapro fungicide is an SC, a suspo emulsion formulation with 3 active ingredients. So you can see that there's really quite a number of these liquid formulations which are in effect combination products. We also took a look at patents of liquid formulations. And what we noticed that patents on EC formulations were from the agrochemical majors and were also made by smaller companies, and those patents tended to focus on alternative solvent systems for EC formulations, so looking for solvents with improved solvency as well as improved environmental impact. Patents on SC formulations include those combination products with multiple active ingredients. We saw a number of patents on SL formulations, which not surprisingly tend to focus on glyphosate liquids, which is clearly the most popular, the most commercially important SL formulation on the market, in particular with alternative salts and formulations containing surfactants as adjuvants. And the patents on OD formulations tended to focus on the use of oil-compatible thickeners, which is a particular challenge to stabilize OD formulations. I just wanted to point out one example of a novel EW formulation patent, so EW oil in water emulsion. And this looked to us like an example, a rare example of a Pickering emulsion. So to remind you what a Pickering emulsion is, a Pickering emulsion uses solid particles at the interface instead of conventional surface surfactants, and those particles act to stabilize the interface between the oil phase droplet and the water phase, the continuous phase. So you're effectively replacing some or all of the surfactant with solid particles at that interface. There's a nice review of an overview of Pickering emulsions, which you can read by following that link there to the review article. And we did spot one patent coming from BASF, which we thought was quite intriguing. This was described as an oil in water emulsion comprising silica particles and a water-soluble non-ionic emulsifier. The formulation contained hydrophobically modified silica particles, as well as conventional non-ionic emulsifiers. And the combination of those two stabilizers was able to give the formulation high storage stability at varying temperature or at low temperature. They also enabled larger amounts of fat-soluble or water-soluble adjuvants to be added into the oil or into the aqueous phase. So there was an improved adjuvancy allowed. The formulation was also claimed to provide higher rainfastness, so presumably there was something about the formulation that enabled it to adhere better to the surface, as well as reduced toxicity and claimed reduced spray drift. I wanted now to cover biological formulations because I think they are starting to drive innovation in the industry. And quite a long time ago now, Alan Knowles' report 2013 looked at new trends in crop protection formulation. And for natural products, for extracts, then the popular formulation types were emulsifiable concentrates, soluble liquid concentrates, and wettable or soluble powders. So very traditional types of formulation being used for natural products. And for living systems, so effectively for microbial biopesticides, then this was dominated by wettable or soluble powders, as well as granules, microgranules, or water dispersible soluble granules, taking well over 50% of the products on the market in those formats. So that was some time ago. We looked more recently in the BioFormulations 2020 report. So here's some further data on microorganism formulation. And we found that for solid products, half of the market was represented by WP, wettable powders, and a further 25% of the market by WG formulations, and then a smaller number of GR direct granule formulations. So you can see some very common formulation types there for solids, WP and WG representing 75% of the products. For liquids, again, a picture of really quite traditional formulations. So liquid formulations of microorganisms, well over half, so 64% were suspension concentrates, 20% were described as soluble liquids, and the rest were other types. So again, quite traditional formulation types on the market. So where is the need for innovation in biological formulation? So like we've seen from the last couple of slides, most biologicals are currently formulated using those traditional simple or established technologies. So for microbials, that will be WP, WG or SC. For oil-soluble extracts, you would be expecting to see those formulated as EC, and for water-soluble extracts, you'd see those formulated as SL. We do think, though, that future demands are likely to lead to more sophisticated formulations. So, for instance, and we'll give you some examples of these on the next few slides, combination products combining both microbial and synthetic actives, and RNAi technology, which is a new technology which we'll describe shortly, which has required some special consideration of formulation. So let's start with the combination products consisting of a biological active and a synthetic active. A well-known example is STK's Regev, in which the natural active is tea tree oil, and that's combined with a synthetic chemical fungicide, so difenoconazole, and formulated as a standard oil and in water emulsion. So there's a combination product, both biological and synthetic in one product. And then a slightly more interesting example, I guess, is that of Poncho Votivo from BASF. This is a seed treatment which protects against insects and nematodes. So you've got two actives in here. The systemic insecticide, the synthetic active is clothianidin, and that is applied via the seed treatment and then goes into the roots of the growing plant and then acts systemically through the plant as it grows in the conventional way. But at the same time is applied Bacillus firmus, which is a bacterium culture, and in the same formulation that is available to colonize the roots and to protect the plant against harmful nematodes, and that's applied as a water-based slurry to the seed. So you can see in one seed treatment you can have both a systemic conventional insecticide and doing a different job, Bacillus firmus, which is colonizing the root microbiome. We did see controlled release formulations in biologicals as well. So here's a nice example of an insecticide formulation in which the active ingredient is Bacillus thuringiensis, BT, and it includes in the formulation a floating agent and a disintegration agent bound on the substrate. The formulation, as you would expect, also includes binding agents, and alongside the BT is a synthetic insecticide. So the granule first sinks and then immediately releases BT, but then disintegrates and releases further BT as it rises through the water column. There are floating agents such as perlite, vermiculite and synthetic polymers in there, so they have a low density, so you'd expect them to act as floating agents, and then binding agents, so water-soluble polymers, and some typical granule substrates such as sand, resin, clay and so on. And then you've got disintegrating agents, which may be cellulosic based or polysaccharide based disintegrants. And this is a schematic, a simple schematic to show the kind of structure that you can build into those structured granules. So around a substrate, which may contain that insecticide optionally. Then you've got binding agents, you've got disintegrating agents, you've got the floating agents, and then on the outer layers you've got the BT coated around the granules. So multiple coating processes to build up those granules in quite a complex structured way. I've mentioned RNAi application. So what is RNAi application? So RNAi stands for RNA interference technology, and that makes use of double-stranded ribonucleic acid, dsRNA, and that can regulate or switch off individual genes in plants and other organisms. So you'll see examples of RNAi technology being used to attack pests and to attack plant diseases. So what's quite interesting with RNAi is that foliar application, so-called exogenous application of dsRNAi, is starting to be introduced. For instance, Bayer with Novozymes, Greenlight Biosciences, Plantarc Bio, and Renaissance Ag are all companies that are now starting to develop products based on foliar application of dsRNA. And here, RNA is a very sensitive biomolecule. And so really the key job of formulation is to maintain the stability of that RNA in the formulation and in the application. So that's really where the need for innovative formulation is expressed. And quite interestingly, what we are seeing in this field are the development of platform technologies for formulation and delivery. And these platform technologies, the idea of a platform technology is a technology that can be used across multiple different actives without having to change the formulation technology very much. And there are some nice examples of platform technologies for RNAi. We've found quite a few already being developed by specialists. So Agricell from Agrospheres is a technology based on cells, biodegradable cells, and actually the encapsulation is done in one step. So the fermentation process that produces the dsRNA also encapsulates the dsRNA inside a cell, which acts as a microcapsule for the active ingredient. Plantarc Bio have a lipid-based formulation and delivery technology for our RNAi foliar application, and this closely resembles lipid nanoparticle technology, the kind of technology which has been developed for mRNA vaccines for human healthcare. So there's a very interesting crossover between human vaccine delivery technology and RNAi formulation technology for plant applications here. Renaissance Biosciences used yeast cells to encapsulate and deliver RNAi material, and there's a technology from Trillium Ag which is called Agrisome technology, where they've used proteins, naturally based proteins, to produce nanoparticles which act as a delivery system for dsRNA. So really quite innovative processes going on, and a strong overlap with the world of healthcare and medical applications. So as we finish off today, here's a brief summary of what we've covered so far. So we've seen that for synthetic pesticides, development in established formulation technologies are quite slow and incremental. The traditional formats remain dominant on the market. The more innovative technologies, capsule suspensions and microemulsions, for instance, remain commercially relatively small and are employed as problem solvers rather than as mainstream formats. But pest resistance is driving the development of complex formulations based on multiple active ingredients, with suspensions, emulsions and solutions of different actives all combined very often in one single product. Innovation is also happening in the biological area, for instance those combination products we've talked about for IPM type applications, and those new methods such as RNAi driving the development of platform technologies. And for that reason, we would expect those drivers that we've described above to continue to accelerate innovation in specific targeted areas such as biologics and combination products as they increase in importance in the future. So just before we finish, I wanted to say, how could we learn more? So I've referred to a number of special reports from IHS Markit during the course of this discussion. They're all available, as we see here, on bioformulations and crop science formulations and sustainability. There's also an online training course available between 8th and 10th of November, where we are presenting that training course on behalf of Inform and New Ag International Academy. Details here. And we, as a consultancy company at iFormulate, would be delighted to hear your formulation challenges, and there are contact details again. So just to finish off, thank you very much for listening today. It's been a pleasure, and thank you very much for the invitation to speak to you today.